A very good morning, dear students. Myself, Professor Sathish Hande, from the Department of Mathematics, KLS, VDIT, Halyar. So, in the previous session, we have studied about Cauchy's theorem, Cauchy's integral formula, and example based on that. So, next it is we will start with the model one. That is, it is nothing but the first lesson. We are going to study recapitulation of limit, continuity, and differentiability, and also we are going to study what is complex function and what is the limit, continuity, differentiability related to a complex valued function. The course learning outcomes is to provide the insight into the application of complex transformation or complex function, and course learning outcome to use the concept of analytic function and complex potential to solve the problem based on electromagnetic theory. The body of the lecture is what is what do I mean by neighborhood, what is function of a complex variable, what is limit, continuity, and differentiability. Now let's begin. Let's have a recall of what do I mean by which you have studied in PUC, that is what is complex number. A number of the form z is equals to x plus iy, where x comma y are real and I is equals to root of -1 is imaginary. I is imaginary is called a complex number. Neighborhood. A neighborhood of a point z0 in the complex plane is the set of all points z such that mod of z minus z0 where delta less than delta, where delta is small positive real number. Now what is the meaning, geometrical meaning of the neighborhood? If z0, suppose that z0 is equals to x0 plus I into y0, then mod of z minus z0, mod of z minus z0, because z is equals to x plus iy, z0 is equals to x0 plus I into y0, so it will be mod of z minus z0 will be equals to modulus only. You are knowing that it is square root of under square root x minus x0 square plus y minus y0 square. Okay, so it is, if you take this, then it is equals to mod of, as if you take the equality, because you know that mod of z minus z0 is less than delta as per the definition of neighborhood. Now if you consider mod of z minus z0 is equals to delta, that means square root of x minus x0 the whole square plus y minus y0 the whole square is equals to delta. Squaring both sides, you will get here, that is x minus x0 square plus y minus y0 square is equals to delta square. What does it represents? It represents circle with center x0 y0 and radius delta. Geometrically, that means geometrically a neighborhood, we usually denote it by abbreviation, that is NHBD, and geometrically a neighborhood of a point z0 is the set of all points inside a circle having z0 as the center and radius delta. That means if you, here I will show, if you draw a circle with the center at z0, then all the points, and here you can see the radius, it is what, delta, and all the points, set of all points which lies inside and on a circle that represents the neighbor, those points are in the neighborhood of the point z0. That like that. Function of complex variable or complex function, we call it as. Now as we know, let us assume that let capital S be a set of complex numbers. If each complex number z belongs to S, there exists, for each complex number z belongs to capital S, there exists a unique complex number w by some rule, then w is called as a complex function of z. Means what? W is a mapping, w is mapped onto z. In general we can say that w is mapped onto z by using some function f. So visually denoted by w, and the function w, it is denoted by w is equals to f of z, or simply we denote it by w. So for example, you can see here, if I take f of z is equals to z square, if I take f of z is equals to z square, but you know that z is equals to x plus iy, and f of z is nothing but w, which is u plus iv. We will take u plus iv, and which is equals to x plus iy the whole square. Now if you take the square of that x plus iy, that is x square minus y square plus I into 2xy. So therefore, if you separate the real and imaginary part, you will get u is equals to x square minus y square and v is equals to 2xy, which is nothing but the, I can say that, image or the transformation of the point x and y. So x plus iy, z is equals to x plus iy, which is transformed to w is equals to u plus iv, with u is equals to x square minus y square and v is equals to 2xy. Now next definition, it is, now as you know, there are some standard complex function. Polynomial function, we can say that it is a complex function. Polynomial function can be expressed as a complex function. The rational functions can also be expressed as a complex function. Even exponential function, trigonometric function and logarithmic function can be taken as a complex function. Now next definitions are limit, continuity, differentiability. Now already you have studied the definition of limit, continuity and differentiability in PUC. So here limit, continuity, differentiability you have studied with respect to real valued function. Now you are going to study the real limit, continuity, differentiability definition with respect to complex valued function. Now let's begin. What is limit? A complex valued function f of z defined in the neighborhood of the point z0 is said to tend to a limit L as z tends to z0 if for every epsilon greater than 0, however small, there exists a positive number delta such that mod of f of z minus L is less than epsilon whenever mod of z minus z0 is less than delta. That is, in short, we can say that limit of f of z as z tends to z0 is equals to L. Now here I have drawn a figure. You can see here there are two planes. One is z plane, second one is the w plane. Now in the z plane you can see that in the z plane, if I take a circle, if I take here circle with center at z0 and radius as delta. Now I have taken all the points in the neighborhood of z0. Means suppose that z is any point here in the neighborhood of z0. Now that point z is mapped onto f of z. Okay, now the condition is here limit, that is limit of a function f of z. Now limit of function f of z tends to limit of f of z as z tends to z tends to z0. As you know that f of z is the image of z, element z, and the element z is in the neighborhood of the point z0. Now if I draw a circle in the w plane with center as L and radius as epsilon, you can see here radius as epsilon, then limit of f of z, as you can see that z tends to z0 is nothing but it is f of z will tend to L, means as z tends to z0. That is only the definition of limit. Now continuity. A complex valued function is said to be continuous at z is equals to z0 if f of z0 exists and limit of f of z as z tends to z0 is equals to f of z0. That is, instead of previously you have said mod of z f of z minus L is less than epsilon whenever mod of z minus z0 is less than delta. Here the condition change, mod of f of z minus f of z0 is less than epsilon whenever mod of z minus z0 is less than delta. Differentiability. Now what is differentiability? A complex valued function f of z is said to be differentiable at z is equals to z0 if limit at z tends to z0 f of z minus z0 upon z minus z0, which is nothing but f dash of z0, exists and it should be unique. And you know that if f of z is differentiable, then it is continuous, but the converse is not true. That is, differentiability implies continuity, but continuity doesn't imply the differentiability. Now the next is now very important concept of analytic function. What do you mean by analytic function? A complex valued function w is equals to f of z is said to be analytic at a point z is equals to z0 if f dash of z exists and it is unique at z0 and also in the neighborhood of z0. See,
what does the definition says? A complex valued function w is equals to f of z is said to be
analytic at a point z is equals to z naught if f dash of z exists, means derivative of the function f of z exists. That means what? We should know the differentiability. If we want differentiability, then we should know continuity, and if you want continuity, we should know the limit, and if you know the limit, we should know neighborhood. So one and other definitions are what? They are interlinked. So that's why if you want to understand the definition of analytic function, you should know the all previous basic concept with respect to calculus, that is limit, continuity, differentiability. Now once again, a complex valued function w is equals to f of z is said to be analytic at a point z naught. Z is equals to z naught if f dash of z exists, means derivative must exist at the point z naught and also in the neighborhood of z naught. Not only at z naught, but neighborhood, how many points? You know the neighborhood, how many points are there? At each and every point it should be differentiable. Then only we say that f of z is analytic in that particular region. And here you can see the note, if f of z is analytic at the point z is equals to z naught, then it is differentiable at the point z naught, but converse is not true. Here also analytic function is also called as a regular or holomorphic function. Okay, with this next class we will be studying the CR equation or the Cauchy-Riemann equation with respect to Cartesian and polar form. Now here, to summarize today's session or topic, at the end of the session students will understand what do I mean by function of complex variable, what is limit, continuity, differentiability, what do I mean by analytic function and all. Now as application part, imaginary numbers or the complex numbers that are used in real life application such as electricity as well as quadratic equations in quadratic planes. Imaginary numbers show up in equation that don't touch the x-axis. Imaginary number becomes particularly useful in advanced calculus. And here are some additional references I have quoted through YouTube channel. So I request each and every one of you to go through this channel. So with this I conclude today's session. Thank you.